As I said in my introduction earlier, my name is Brendan Thiede, and I'm a DevOps engineer at the Michigan State Supreme Court. I'm constantly trying to learn, so I do lots and lots of podcasts at double speed, and sometimes it's enough to give my wife a headache, so I have to, turn it off while we're in the car together. And one of the things I want to do is I want to maximize my impact. And so what I mean by that is I want to share things that I've learned. I want to help build up the community around me. This is one example of how I might try to do that. But there's also, I heard some people talking about it earlier, there's going to be a global Azure boot camp at the end of the month. That's going to be a really cool opportunity. If you've never deployed software before, this can be a chance for you to see what that's like in an automated fashion. You get like Azure credits, kind of fun bucks to be able to use in Azure. It's $80 worth of credits, and that can take you a long ways. Yeah, you can do a lot with that. You can spin up toy VMs for playing with stuff, things like that. But that's at the end of the month. If you're interested, you can go to the DevOps Meetup, and you'll see that event, and you can RSVP for that. Or if you know anybody who'd be interested, let them know. And so, of course, the most important part of this evening is the buzzword bingo. So the rules are that you have to either wait for the term to be said by me or for it to appear on the slide, and then you can mark it off on your card. And we're just doing the 5 terms in a row, diagonally, horizontally, vertically. So we're not doing any postage stamp or 4 corners. Trust me, we've got enough words to get through. We don't need to worry about that. And whoever says bingo first, you get to come up and pick out one of the prizes over here. So the options that we have, we've got an insulated water bottle, a tumbler. There are 2 books you can choose from, and then a power brick thing. Eric and I were debating what you actually call it. I don't know, but it's for your phone. It gives you power when you need it. And you have to say bingo, or you're not going to be acknowledged. And so if 3 people get it at the same time, whoever says bingo first gets to pick first, and then on through the line. But before we continue, I need everyone here to raise your hand, okay, and say with me, okay, I state your name, do hereby solemnly swear to never use buzzwords, slang, or jargon.
Slang or jargon.
Yeah. With the intent to belittle, baffle, or hoodwink my fellow human beings. Okay. So there's no going home to your significant other, and when they ask, why do you smell like a distillery? You can't say like, well, I was sanitizing the Helm charts to push out the Kubernetes deployment, and that's why. You can't do that, okay? And that's actually part of my motivation for this talk was I know that I use a lot of terms that I assume people know what they mean, and they don't necessarily, because they come from different experiences, different backgrounds, and that doesn't mean that they're any less equipped to do an effective job. It just means that they don't have the same vocabulary, same context as I do. And so hopefully we can demystify some of that tonight. So,
can I jump in real fast?
Yeah.
So if anyone's welcome to sit at any of these desks, or there's extra chairs, just throwing that out there.
Yeah, if you want to shift around, need to shift around.
Can we use the jargon to get management off our backs?
That seems a little disingenuous.
Unless you're management.
So if you're management, getting management off your back, you can use the jargon?
You can't use it if you're management.
Oh, you can't use the jargon if you're management. Okay. So I guess to start with, let's throw out perhaps the biggest buzzword of them all right now, DevOps. What is DevOps? And so I like to steal the definition that Donovan Brown gave on his blog. He says that DevOps is the union of people, process, and products to enable continuous delivery of value to our end users. And if you look for his definition of it, he goes into why he picked the words he chose, why he said it the way he said it. And he really wanted to focus on its value. It's not necessarily software, because it's any number of things that go into that. But I can tell you what DevOps is not. So it is not a role. I'm saying that as a person with a title of DevOps engineer. I don't do DevOps. I definitely don't do the DevOps. I'm somebody who advocates for DevOps. I train people on what different DevOps practices are, and then the engineer portion of it is where I actually build some tools to help make that an automated thing and help people out with that. It also is most definitely not getting rid of operations or getting rid of QA or getting rid of security. DevOps is about reducing friction between some of these areas. It's about maybe shifting some responsibilities within that, but it doesn't mean that just because a developer has the ability to deploy to production, it means that they have the expertise and the experience to understand the consequences of what that might mean when they are ready to go. And so you might need to have consultations and coordination and collaboration. It's also not a methodology. A lot of things get called methodologies that are not methodologies, but clearly from the fact that DevOps is not prescriptive, it's not a methodology. However, there are a lot of kind of proven practices that can help you. A really good book that was released about a year ago is Accelerate. It has a much longer subtitle, but it goes through the researchers who put together the State of DevOps report. Yeah, that book that Tilak has there. Yep. It's a really good book, and it shows like practices where they show consistently, you do this, and you're probably going to be a high performer. The low performers do this. You probably don't want to do that. So good book. So where did DevOps come from? Well, we had a lot of the Agile stuff. This came out, Agile Manifesto is now 18 years old, I think. 18, 19 years old. They had all these methodologies already. There's already Extreme Program. There's already Scrum. These guys came together, did whatever they were doing out there in Colorado, and they came up with the Agile Manifesto where they agreed on this is a good way to develop software. But where that got focused on was really at the development team level. So who here uses some sort of an agile process? So a lot of people. How many people would say that they have a DevOps type mindset? So fewer, right? And that's really where DevOps came from, was this shortcoming. And so it steals a lot of ideas from lean manufacturing. So one of the key things is value stream mapping. That's an idea that comes out of there, where you're visualizing your whole end-to-end flow. So it's not just about how fast can we do things in development, it's how we get things through the whole system. And one of the key values of a value stream map is that you're going to be able to identify your bottlenecks, because the theory of constraints tells you that any improvement besides the bottleneck is just a waste of time. So just don't do it. Focus on the bottleneck. And so if your development team is humming along and they're cranking out quality work sprint after sprint, but then it takes 6 months to deploy it to production, doesn't do you much good to send people to more Scrum workshops and implement different tools within development if we're not addressing downstream value. And you want to reduce inventory, so that's your batch size and lean, stuff like that. Your inventory is a little harder to identify in software because it's invisible. In the novel, the Phoenix Project, which is a lot of the people who are leaders in the DevOps movement, they put together this novel, and there's a lot of visuals in there where they're going up to this catwalk and looking down on a factory floor, and they're seeing things move. It's a little harder with software, but there are things you can do. Putting together a telemetry in your pipeline and stuff like that. And then shift left is another key term that you hear around DevOps, and what that really means is bring things into your pipeline as early as possible. So if you can do dynamic scanning on every single commit that gets deployed to your dev environment, do that. Don't wait until it gets ready to deploy to production and then hand it off to a security guy to then do some penetration testing or anything like that. Try to shift it left in your workflow. If you assume things are flowing from left to right, try to shift things as close to the left as possible to give you faster feedback. So now we're going to move on to some of the things that are involved in implementing DevOps. So one of the things is security. A key practice that you can do in security is threat modeling. Threat modeling, there's a really cool tool that Microsoft has, the threat modeling tool, and it's a free tool that can help you diagram your infrastructure. It can be good for identifying your components, but the other cool thing that it does is it'll automatically tell you things that you need to worry about as far as, hey, there's network communication between this and this. You should encrypt that traffic. There's communication between this service and this service. Maybe, you throw that behind a firewall so that it's going to be less exposed. You've also got your static analysis. That's where you can use something like SonarQube. That's a free server that you can stand up and it can do certain scans of your code, or you can engage third parties. And then dynamic scans and web application scanning, that's where, I should back up a little bit. The static scanning is where it's scanning your source code itself and it's looking for different patterns in your source code. So it might say, hey, I see a heuristic here that tells me that this pattern is likely to indicate that you've got a SQL injection vulnerability. And so it'll call that out for you. Or it'll look at things in your JavaScript and say, hey, that you could totally have some clickjacking going on here. Whereas the dynamic scans, that's more, you've got a running application and it's working like a user might or a bot might, and it's going to try to do things like, if there's this possibility of input, it's going to try to do SQL injection to see what it can do. It's going to try to do some cross-site scripting to try to see what type of vulnerabilities it can expose. And these are things that, you're as much as you're willing to pay, there are going to be companies out that are willing to take the money, but in the end, it can all be completely automated, and it can give you really high confidence in your security posture. Continuous integration, this is kind of table stakes for a lot of DevOps type stuff. So first and foremost, you need everything in source control, everything, and we'll continue on what everything is as we go. It's a good idea to have a common build server. So this could be, I listed Azure Pipelines, GitHub, Actions, and Jenkins. Those are all at least somewhat free. The Azure Pipelines and the GitHub Actions are completely free. GitHub Actions is a new thing if you're not familiar with it. And then Jenkins, you need to pay for processing power somewhere, but the software itself is free. And it has a large open source community behind it, so there's a lot of plugins to do a lot of things for your builds. And the reason that I would suggest having a common build server is that you don't want people to say, well, it builds on my machine, runs on my machine. If you have a consistent single source for all your builds, you're going to have more confidence that it's a consistent thing going on. And then one of the keys of continuous integration is that every push, or whatever version control you're using, whatever the semantics are there, that's going to trigger a build. And that build should include, at a minimum, some sort of unit tests, all right? And it's going to package your deployable. And a key thing here is it should only be once that you ever package that, all right? So if you have, for example, connection strings to databases, those are going to be different per environment, right? That should not require rebuilding your software to be able to get that configuration change. You need to make sure that all those configuration points are external to that packaging process so that you're not rebuilding for every environment. Because otherwise, you're going to lose confidence in what it is you're deploying. A key example of that would be if you use Node. So you do npm install, and depending on how you define the dependencies, unless you're going from your yarn lock file or your packages JSON lock file, it's potentially going to grab newer versions of different dependencies every time you build. And so it's possible that the version that you were testing is different than now the version that you're going to deploy to a different environment. So package once. I'm done on that soapbox. And then, static analysis, mentioning that again, that's something, static analysis at a minimum should be in your build pipeline, that automatic continuous integration, because you don't need to have the environment deployed to be able to run the static analysis. Okay. Next, infrastructure as code. So this is the continuation of everything as source code. So this means that you're going to have all your configurations in for your infrastructure. You're going to have that as source code. So for me, I use ARM templates because I use Azure, but you can use Terraform, you can use CloudFormation, all these different other things. But the key is this is where it's going to define what that actual infrastructure is. So for me, it might be I have a VM, and that VM is going to have 2 hard disks, and they're going to be 512 gigs each. It's going to have 4 cores and 8 gigs of RAM, whatever it is. And these can be either declarative or imperative. I prefer declarative syntax for these types of infrastructure management type things, because that declarative syntax, you're just going to say what it is you need, and it's up to whatever tool it is you're using to figure out what it needs to change. So for example, if I say, for my VM that had 4 cores, now I want to scale it to 16 cores, it'll know, oh, I need to move to new hardware, so I'm going to provision something new, move everything over. Versus imperative, it's going to be more do this, then this, then this, then this. That can be more tedious if you want to be able to apply that to existing infrastructure, because you've got to have it check what is the value of this already. Did it change? Did it change up? Did it change down? What do I need to do? I don't like doing that as much. It's just easier if I can trust the tool to do the work for me. But either way, it should be idempotent. And if you've not heard the term idempotent, it's something that especially the guys at Chef like to throw around all the time. And idempotent is just a mathematical term that means you perform the operation on the results of the operation and you get the same result. So you can imagine like multiply by 0. If you multiply a number by 0 and then multiply the number by 0 and then multiply the number by 0, it's still going to be 0 at every step all the way there. And so the idea here with saying that these are idempotent is that you can apply your infrastructure definition, and if there are no changes, it's not going to be a problem. It's still going to work, and you're always going to end up in the same result. You have the same declaration, no matter what the state of that infrastructure is, it's going to end up in the same final state. And then I have question marks next to environment variables. This is something where it might depend a little bit on the types of technology you're using as to whether environment variables are going to be part of your infrastructure as code or whether they're going to be part of configuration management. For example,
Bingo!
You got bingo? All right. Come on down. So is the environment variables, what was it? Or configuration management?
I was
Nice.
waiting for you to say it.
All right, so any one of those things there. The power brick is the thing in the white box. Yeah, that's the insulated water bottle.
All right.
Cool.
Nice work.
There we go. All right, so configuration management. This can go by some other names as well. Some people blur these terms a little bit, but a lot of times you hear it called desired state configuration. In fact, in Microsoft, there is the tool called PowerShell DSC that is for its desired state configuration. And so the idea here is this is what's going to run on existing infrastructure. So you've got your infrastructure as code that might define a VM for you. So you've got a virtual machine out there and it's got an operating system on it and all that. Now you're going to take and apply your configuration management, and it's going to say, oh, we need these packages installed, we need this PHP configuration, whatever it is. It's going to take care of making sure that all that stuff's set up. And again, this can be declarative or it can be imperative. And again, it needs to be idempotent. And if your environment variables were not part of your infrastructure as code, just because of whatever the nature of that service is, you are going to want to have them as part of your configuration management. If you're using Chef, that's going to be through like your encrypted data bags, or in Ansible, you can have encrypted secrets. But the idea here is you want to be able to deliver the configuration to the environment so that when you push that source code or that application that we built from our source code, that is going to be able to pick up the environment variables that are already there, and that's going to cause it to behave in a way that's appropriate for that environment. So if it's your database connection, when you deploy to dev is already going to have an environment variable that's my database connection string, whatever you call it, and for dev, it's going to point at dev. And that same environment variable name is going to exist in production, but it's going to have a different value for where it's going to point to. Let me point out though, those secrets, so like username, password, any sort of credentials, Never, never, never have those in your source control. Never, ever. You can encrypt them and put them in there that way. I'm cool with that, but never have passwords in your source control. There are better ways to handle it. So let's go ahead and take the jump and let's get to the cloud. So there are going to be quite a few terms here, so people might get some bingos here. So this is a nice diagram that I completely stole from Azure. So this is their kind of shared responsibility model. And so along the top, you've got the
Do I
different...
get bingo for the acronyms?
Yeah,
Bingo.
okay.
Bingo. Infrastructure, platform. I mean, they're all up there.
They are. All right, pick your
Good. I
swag.
need that brick.
Yeah.
I gotta go charge my phone.
Oh, wait a minute.
Yeah, so that was a little cheeky because
Nope.
you knew what the acronyms were. Yeah, so the idea here along the top.
Can I take this, right?
Yeah, go ahead. Along the top, you've got different deployment models. So if you deploy on-premises, that's the first column. Infrastructure as a service. So that's where it's like, for example, a virtual machine. That'd be the most obvious. Infrastructure as a service. So the next would be a platform as a service. So in Azure, you've got app services, where it's something already pretty much running. You just need to provide your source code. And then there's software as a service, and that's something like, Salesforce, something like that. If you use a hosted version of Jira, things like that, that's software as a service. And then coming down the side, you've got the different responsibilities.
Where would Heroku fall in that?
I would say that Heroku is platform as a service.
Okay, thanks.
I concur.
Okay. Yeah, I mean, some of them there's kind of debate. Like, for example, in Azure SQL database, I think that's kind of platform as a service.
SQL. It's a software application.
You think it's you're saying that's more software as a
I
service?
think it's which flavor you'd use now.
Yeah. Well, yeah. There's also the different. You could choose the
Like
managed
3 different flavors now,
instances.
so I think it
and-
might
yeah.
change a little.
Yeah, I'd say it depends on how, are you deploying code into it, or are you more just using it to store data? So yeah, there are things where there's some wiggle room. I'd say Heroku is kind of like a platform as a service, because you're providing the code to make it run.
Okay, what about DigitalOcean?
DigitalOcean is more platform as a service, but
So I'd say it's infrastructure.
yeah, you can use it more like infrastructure
You have
as a
to
service.
pick it if you want a software. So it's infrastructure because you have to pick the software that you're going to use, and they're not managing that software either.
Right.
And
Yeah,
that's
so
kind of the distinction in my mind is platform is fully managed software, or software is fully managed, platform is partly managed.
Yep.
Infrastructure is you have to deal with the management of whatever software.
Yeah.
Even though they have those little pre-configured droplets, once it's deployed, you're managing it.
Yeah. Yep. Yeah, and this model here is meant to show kind of what are the things that you no longer have to take care of as you move to the right, or what are the things if you're coming to the left that you're now responsible for. So like switching from on-prem to a third-party cloud provider, you don't have to worry about physical security anymore. That's now somebody else's responsibility. But you're still through all of these identity and access management, that's still your responsibility. Even if you're using a fully SaaS solution, if you're picking crappy passwords, shame on you. You're still responsible for managing your passwords correctly and usernames and things like that. Not writing it up on the whiteboard and stuff.
I erased it.
All right, cool. And so within the cloud, some of the things that you get to kind of pull some knobs and levers on are scale and cost. They're pretty much going to be tied to each other. And if you want to be able to effectively use the cloud, you really need to be able to understand both these things, because otherwise you're just throwing away money. So you need to be able to scale up, scale down, scale in, scale out. So what that means, so to scale up, if you think of like a VM, you're picking something with a larger processor, more RAM. Okay, so that's scaling up. Scaling out is you're making multiple copies of the same thing, and then you're going to be able to pick which instance is going to take care of different workloads. But it's not just scaling up and scaling out, it's also scaling back in and scaling down when you don't need it. If you have just a really constant workload where, for example, you've got a VM that's just always on in the cloud, guaranteed you're going to pay way more for that than if you already had a data center, and already had hardware on premises. You could run it there for next to nothing. Another way to take it. What's that? Bingo. All right. All right.
2 prizes.
Yep, we got 2 left.
Okay.
So there's the functional programming.
What can I do now?
All right. All right, so the last person to get a bingo gets a copy of Functional Programming for Java developers. Okay. Another way to take advantage of scale in the cloud is through some of the serverless, they call them, or consumption-based models. So with consumption-based services in the cloud, you're going to be able to pay for just what you're using. And that can be very useful if you have a dynamic workload. So something where it's very bursty, where it's certain times a day people are all of a sudden doing stuff, or certain times a year there's a lot more activity. You can imagine if you have some sort of a cat photo sharing app, there might be certain times a year where more people are adopting new kittens, and so they're going to be taking lots of pictures before they realize that the cat is just pure evil and they want nothing to do with it. And so you might have a lot of flow through your system during those times, but then maybe other times it goes down to nothing. And I put a little bullet here about OpEx versus CapEx. So these are things you might hear talked about. So OpEx means operating expenditure. And so that's where you're paying for something based on what you have used. So for example, in Azure, the Supreme Court gets a bill at the end of each month that says you spent this much this last month, so this is how much you owe. Versus CapEx is a capital expenditure. And so that's where you need to, let's say, depending on what your cycle is, it might be 4 years out. You need to predict what your needs are going to be. You need to do capacity planning, and you're going to need to figure out what new hardware you need to buy, stuff like that. And so you need to budget that all up front, which, if we go back to the idea of scale, you're going to have to over provision, right? So if your heaviest workload is going to be dealing with, Christmas Eve orders, you need to buy infrastructure that can handle that amount with a capital expenditure. So that can be a little harder to predict sometimes. But there are going to be situations, if you've got a steady known quantity of work, it might make sense to keep it that way. And then a couple concepts around being able to take advantage of the cloud are around stateless and batch workloads. So the idea with a stateless workload means that there is nothing special about that particular instance of an application that's running. So if you have a web app, right, you should be able to have somebody go to one instance of it or another instance of it, and nothing is sticky about that user. The moment you have any sort of state assigned to the application, it's going to be much harder to scale, because you're going to have to figure out how do you keep people sticky to a particular session. How do you, when you start scaling out, start starving connections to one service and now start hydrating another connection to a service. It's just a lot trickier. And then your batch workloads, that's a great thing. If you've got, let's say, ETL jobs would be a really common batch workload. This is something where if you're using a cloud provider, you can have infrastructure that doesn't even exist all day long, and then you just spin it up in the middle of the night. And typically you're paying per, processor hour, processor minute, whatever, however they charge, which means if you have a single 4-core machine that runs for 20 hours, or you have 20 machines doing that same amount, you could get it done in an hour instead of 20 hours, and it'll cost you the same. So that's those are the types of things you might think about with this type of thing. And then we've got, of course, containers. This is an easy way to shift workloads around. And so along with containers, you get some other words. So you get microservices. What's that? You got a bingo?
You did.
All right. I'm a guy who deals with a lot of these types of terms.
The last prize.
All right. No prizes left, but we're gonna keep going.
Grab some stickers if you get bingo.
Yeah, there's stickers up there too. I saw some pretty cool ones up there. So anyways, containers are a way of holding your application and some of the runtime bits that it needs and dependencies and having that all together so it's easy to just have this single thing that you just push somewhere and it runs. If you have a container and it's stateless, it makes it very easy to make more and more and more copies of that container. And so along with that comes a pattern of microservices. So the idea with microservices is you have independent little components that are going to work on little pieces of things, and they're going to be loosely coupled, and typically they're going to communicate with each other over REST or something like GraphQL, something like that. Orchestration and scheduling. These are two things that I hear people kind of merge the terms together a lot of times. But the way I like to think of it is orchestration is kind of a bigger picture. What are all the things that need to run together? So Kubernetes is a very popular orchestration platform, but within it, it has a scheduler. And in fact, you can swap out the scheduler to be a different scheduler if you want to. And the scheduling is the idea of, for this workload, you're saying I need this much compute, this much RAM, whatever, find a place where I can run. And the scheduler is going to make decisions around where it should actually have that running. And there are going to be lots, scheduling is one of the most complicated things you can imagine, because it's going to make choices based on, is this workload preemptible? Meaning, can it be just cut off in the middle? Is it something that can be restarted easily? Is it something that needs to be geographically close to something? For example, it needs close network proximity for database calls or something like that. There's a lot that goes into that. But I mean, that's the key to what all computing has been since the very first computing, where the scheduling was you stood in a line waiting to go up and program in your thing, to eventually it was punch cards that were scheduled, where it was, okay, this department gets their punch cards run, and then the next. And then it just becomes more and more complicated as you now take and try to fan out processing power, but then reconverge it together into what we call the cloud, which is part of that whole fan out, fan in. This is a pattern that was made very popular by like Hadoop. So that's where you take a job, you split it up into a lot of little pieces, do all the work out there at these individual nodes, and then bring it back together and get a total. So that can be a really effective pattern for doing something very quickly, where you can scale out to a lot of infrastructure, but then get a result very fast and then kill off the stuff that you don't need anymore. But all that involves distributed systems, and distributed systems are hard. And they are hard for many reasons. One of them could be networking. So we talked about most of the times, if you're doing these microservices or whatever, you're using REST. Oops, actually, I jumped ahead, didn't I? Darn it. So this is my mathematical formula. It is absolutely true. Do not refute it, for microservices. So if you have a service that needs to independently scale, so if you would gain benefit from scaling this one thing independently, and if you absolutely need to be able to deploy this thing by itself, like you can't redeploy other pieces that haven't changed, right? And if your interop speed with other things around you is negotiable, then go ahead, make a microservice. Otherwise, stick with what you have. Because by switching to microservices, you are adding a lot of complexity, and you are inherently slowing it down, right? Because you're having to jump processes, jump systems to get an answer to a problem. And then a lot of there are benefits that you can see beyond this. I'm sure people can think of things where a microservice might give you benefits beyond these things. But all the ones that I can think of beyond these, you can also do within a single code base. A lot of people use the term monolith. It is intentionally chosen to represent something kind of heavy and crusty and not very good, but it's not a bad thing. I actually have a link that I'll share at the very end to Martin Fowler's blog, where he talks about some of the trade-offs that you might have going between a monolith and a microservice, and it's a really good discussion of it. Okay, so now for real networking. So within networking, you need to figure out where things are. And so that's the idea of service discovery. So if you've got all these things popping up, and then disappearing, you need to figure out where are they. So if you've got 20 different services for saving your cat pictures to Redis, you need to know where these things are. And so one of the ways of doing that is through a service mesh. A service mesh kind of encapsulates a lot of these concerns around some of your networking, some of the service discovery and stuff like that. And one of the patterns for that is what's called a sidecar. So if you hear somebody talk about a sidecar, that means that in the context of, for example, Kubernetes, you've got a pod, and so that pod is going to have several containers. And so one of those containers is going to be your service mesh type thing. So Envoy was something that was created by Lyft to do this. And so what you do is every single request you want to make for anything, you make it to that sidecar, to that proxy. And so if you want to find the cat meme generator service, you tell that, I need an instance of the cat meme generator. And that's going to take care of directing your traffic to where an instance of that actually is. And it's also going to be able to do things like handling encryption. It can handle certificate rotation for like TLS. It can also handle credentials for you. These are all things that you can benefit from in that sidecar type process. But you can also do that through having common libraries in your code that can take care of service discovery. But in the end, just be aware that with all these things popping up and disappearing, you need some way of orchestrating them all. You need some way of passing information between them. And this is one way.
Would you also use a sidecar to, let's say, if you had insert like Kerberos tickets into your configurations into your container or something?
Yeah, you can use sidecars for things like that. So sidecars aren't used just for networking stuff. They can also be used for like distributed tracing, things like that. Well, I guess that's kind of a networking thing. Yeah, logging as well. So yeah, anything that you have like a common way that everything wants to do it. You can think of it, one way you could do it is, you create, a jar file or, DLLs or, whatever the semantic is for your languages that you're using. So you can create a common library that you then consume by the individual things, or you can create an external thing. I actually just listened to a podcast with some of the engineers at Uber, and they were talking about how they actually don't like the sidecar approach, which is kind of funny because Lyft, their key competition, is like big advocates of it. So maybe that's why they don't like it, just because. Another key thing to keep in mind is load balancing. So load balancing can be dynamic. So you can have it where as services are spinning up, they're registering with a load balancer, or it can be static. And so the idea with a load balancer is you've got one entry point into your system, and then that's going to make a decision about where you need to go. And so if we have several VMs, right, we can have different ways of load balancing. And so that load balancing can be based on just a round robin. That's a very simple strategy where it's who did I last route to? I'm going to go to the next guy in sequence. Or it can be stuff where it's actually inspecting how much load is on a given machine. So if something's running some big batch jobs, it might not route any traffic there for a while. It might stick to others. Or you can have, if you have those kind of stateful workloads, which you should avoid if you can, but if there's something where a user logs in and they create a session and that session is stored on the actual VM, then you might want to do something where your load balancer, it's very common to have a cookie that the load balancer is going to assign, and then every time your web browser tries to come back to that load balancer, it's going to look for that cookie and say, oh yeah, I know you need to go to VM number 1. Because if I send you to any of the other ones, you'll be logged out. Within load balancing, you have some choices. I am not going to claim to be an expert in any of these. I'm just bringing these up as these are things you should consider. So you can do very common ways of load balancing. For the scale that I would assume most of us are at is layer 4 or layer 7 networking. So at layer 4, it's going to be very fast, but it doesn't have as much context. So it doesn't know that, for example, this is an HTTP request. And because it's an HTTP request, it has certain information in its payload. So it's just going to be able to work on port and protocol. So for example, if you had a Node.js application running behind a load balancer that was responding to traffic on port 443, but the Node.js application is on port 8080, it could be able to do that translation very quickly to say, yep, I know that any traffic I have coming in on port 443, I'm sending to one of these guys on port 8080. That'd be a very simple example of layer 4. Layer 7 is where you might want to do things a little more intricate, where let's say you have different VMs that will be responsible for handling different paths in your URL, right? So you could have a single URL. So of course, I think this domain I'm sure is already taken, but Brendan is awesome. I'm sure people already have shrines to me. So, but if there was Brendan is awesome / complaints, I could have that path in a layer 7 router. I could have that just route to a dead black hole, and then / compliments I could have go to an army of 100 VMs. So because of the layer 7 context, it can do a little bit more introspection into the traffic, but it's going to slow it down some. Yeah, and I already mentioned, some of the strategies you can have there can be either you can be persistent based on a cookie or whatever it is. You can even do it by geography. You could say anybody coming in with this range of IP addresses, always send them to these servers, something like that. Or you can do round and robin, is going to be just a lot easier. Other things to keep in mind with routing, DNS. DNS is important. If you're not familiar with DNS, the easiest kind of entry into DNS is to talk about A records and C names. And so with DNS, so that's domain name service, okay, this is the white pages of the internet. So you have a name for a website, so brendanisawesome.com, and you go to a DNS server. If you want to use Google's DNS servers, I happen to know that those ones are 8.8.8.8 and 8.8.4.4. So there you go, a little bit of trivia for you. But you can put in, it's going to go to, my browser is going to go to that DNS server, and it's going to figure out what is the IP address that I need to go to. And so for an A record in DNS, there's going to be a literal mapping of, yep, brendanisawesome.com maps to, 278.35.75.129. It's going to be that type of a string of digits. That's going to be the IP address for the site. Now, if it's a C name, it's a little different. A C name is going to be basically a redirect of sorts. It's not a true redirect, but what it's going to be is you're going to go and look up that DNS record, and you're going to get a name of a different thing. So brendanisawesome.com could be a C name. If I had an Azure website, it could be brendanisawesome.azurewebsites.net. And so that C name would come back to my browser, and then I'd know, okay, actually I need to look up that guy's IP address, and then it's going to go and find that. And actually I know for a fact that any of those azurewebsite.net, that's another C name that's going to come back with a different IP address. This is useful information because if you can leverage in, for example, a cloud, if you can leverage their existing domain name, you don't have to worry about what happens when their IP address changes. So if you can use a C name to, myawesomewebsite.azurewebsites.net, if you use a C name to that, then if that underlying infrastructure changes, where the IP addresses change or anything like that, it doesn't bother you. It's not going to be a problem because you can't always change that. You can't always control all that stuff, especially in the cloud. You don't have access to any of those things. You can't necessarily tweak what the IP addresses are and stuff like that. Some other ideas here. We talked about reverse proxy at the very beginning. A couple of us were chatting about it. So the difference between a proxy and a reverse proxy, okay? A proxy is something where you know what the thing is that you want to hit. And so you tell a proxy, this is exactly the thing that I want to hit, and it will go out to that thing for you on your behalf, and it will return the response. A reverse proxy, you don't know exactly what it is you want to hit. So you talk to the reverse proxy and tell it about what it is you want, and the reverse proxy makes a decision of where it's going to go and pick things up. An example of this is in Nginx. It's used very popularly for reverse proxy. Apache has similar functionality. And I currently use IIS quite a bit because we're a Microsoft shop at the Supreme Court. And so you have something in there that says, inspect the URL, similar-ish to the layer 7 networking. And it's going to say, I'm going to look at the URL and let's say, if it's got this path or it's got this query string or it's got this pattern in there somewhere, or it can even look at the payload, the actual data that's in there. I'm going to actually make a call to somebody else on your behalf. And that's how a reverse proxy would work. Things to be careful of there are now by default, unless you're using a system that is configured specifically for this and takes this into consideration, it is no longer a user who's making the call. So if we have a server here, and we have a client here, and they want to hit a service that's running here, they're going to come to that proxy, that reverse proxy, and now that is going to make the web request to the thing that you want to actually hit. And so now any of your logging that's trying to log your client IP addresses, the source of that traffic, it's probably going to say that it was that proxy service, your reverse proxy. So just be careful of something like that. Because a lot of times you actually want information coming through. Yeah.
There are ways to pass the client information through.
Yeah, there are some pretty standard headers that you can add to your request. X forwarded for, X forwarded by, X origin. A lot of these X in front of a thing. So these are request headers. In your request headers, you might have things like your host name and things like that. All the X ones are extra that you can add on as they're going through, like Apache or Nginx or something like that. But some systems, you have to make them aware that they need to look for that header instead of just the origin IP address. So we had to do some of the Microsoft stuff didn't do it by default.
You have to add advanced logging.
Yeah. Okay, virtual networks. You're going to encounter virtual networks a lot of places, but where you see them a lot, for example, in a cloud context, would be in a hybrid cloud. And so that's where you've got a network within your data center, and you've got a network in the cloud, and maybe you're using some sort of a VPN or something to connect those. And so that's going to create a virtual private network, or that virtual private network is going to run within a VNet. And so a VNet, virtual network, is just it's a range of IP addresses that, if you're following the rules, are only going to be valid within that network. So there are certain sets of IP addresses that you can't use for global DNS entries, for global web traffic. So for example, Google could never have a website that resolves to an address starting with 192. 192 is reserved for local private traffic. Or 10 is another prefix that is reserved for local private traffic. And those are examples of subnets. There are really cool CIDR notations, CIDR, I forget what it even stands for, but there are multiple ways that you can identify a subnet. There are different formats that you can do it. So you can say there's subnet masking, which if you've ever messed with Windows networking, that's the old, for my network, my subnet mask is 255.255.255.0, which means whatever my IP address is, I will consider things within my network if they have the same first three tuples and only the last number, that last octet there, that's the only part that's different. That's one way of identifying subnets. There are different ways though. You hear people talk about like a /24, a /8, /16 network space. It all has to do with math. Best bet, just Google CIDR notation calculator, and it'll be a good bet. There are calculators out there. They're very complex, the math behind them. Because if you just put in a IP address range, it may not be possible to represent it as a single CIDR notation, depending on what notation you need for the system. So
it's always possible. It just might be a /1.
It might have to be several. I've seen it. There are some where the math doesn't work out, and you actually have to have several notations if you're doing like a slash.
Will cover everything.
Well, you need to be. I'm saying if you want to blacklist specific things, okay. We'll talk about this later. To the bar. And then there's also the idea of zero trust networks. This is a phrase that's been thrown around a lot more lately. And in fact, Google has kind of publicized this whole perimeterless security that they are using. So they no longer have, like, you don't VPN into their network to access different systems or whatever if you're an employee. Instead, it's different ways because they basically are making the assumption that you can't trust anything. And so the idea with zero trust networks is even if it is something that you're housing inside of a subnet that you own and it's inside of your virtual network, you should still assume that it's compromised. Unless there is an absolute need, for the speed. So if you think about it, if we go back to the idea of microservices, we've got all these things communicating over HTTP, right? If you are encrypting and decrypting traffic every single hop, there's some cost to that. There is some computational cost to that. But you really want to think long and hard before you decide that that's too much of a cost and you want to just get rid of it. And oh yeah, we'll just offload any encryption, any TLS certificates, anything like that. We'll offload that at the load balancer, and we'll just leave everything running on just clear text on this side of the load balancer. Because we've got a firewall, we're good. You never know what's going to end up inside there. So the general rule, encrypt everything, trust no one, not even yourself. But with all this complex stuff, outages will happen. And so I'm going to show some ways that you can test outages, but they're not necessarily just for outages. So whitelisting. This is the idea of I only want certain traffic to get to my servers. Right? So this can be something that breaks you if IP addresses change, for example. But this can also be a way to test how resilient your systems are. If you remove yourself from a whitelist, what happens? And so whitelisting is you only have explicit things. These are the only things that can get access to X. Blacklisting is the opposite of that. It's, yeah, we trust things by default, but only these things we're saying don't trust them. One of the ideas that's become very popular is circuit breaking. So a circuit breaker pattern, the idea here is if something is broken, you might not want to hit it with a whole bunch of requests. So for example, if you have an authentication system, let's say that normally, when users go to log in, they get an authentication token, and then they just hold on to that token, and then there's secret information that each of your services has that can validate that token without ever going back to the authentication service. Just trust me, it can happen if I'm not doing a good job of illustrating it. But the idea there that I'm trying to point out is it might be that identity service that authentication service is only hit once a day for your average user, let's say. Well, if it goes down, or let's say you have multiple instances of it and one of those instances goes down, all of a sudden somebody might try to log in and they get a failure, and then it might try again, and it might try again, and it might try again, and it might try again. What you can do is what's cause a cascading failure, right? So you might all of a sudden now flood this thing that maybe was starting to get a little sick, and now it's getting so much traffic that it just completely collapses. And so the idea there with a circuit breaking pattern is you would have something, either in your application or in one of these sidecars that says, yeah, I'm getting a lot of failures to this thing. I have a rule that tells me if I get, 5 failures within a minute, I need to just shut that guy off. And so it will black hole those connections. It'll make it so that you end up just instantly getting a response of a failure. Or maybe if it's a case where there's multiple instances, maybe it wants to go to one that's very geographically near, but now it says, yeah, I need to go the long way around and go to this other instance. But then what that thing will do is you can have that, and this is where a sidecar helps you out a lot, is if you have the single network proxy, and that's the single choice of, yeah, I'm going to stop going through this authentication service, what it can do is it can periodically check that thing for when it's back up, and it can be smart about it, right? So instead of having everybody's slamming it, instead you can have it do, there's the idea of exponential back off. And so the idea there is you might try once every second for a while, and then, well, that didn't work, so now we'll back off and we'll do it once every 5 seconds, then once every 30 seconds, once every minute, and it just kind of backs off more and more, okay? But then once things are back up and normal, you can have rules that say, maybe it's you do, I don't know, 5 healthy pings across the course of a minute, and you get 5 healthy pings, then you open it back up again, or you can actually have it where on the other side it has to report back, oh yeah, sorry about that, I'm healthy now, so please open up traffic again. Yeah?
Can't the circuit breaker also, if you have like maybe that particular call isn't required to complete the task, you can have it just fail off, and so it's a failure, fail open, so it just goes through as well.
Yep.
So you maybe it's an optional, additional information field.
Yeah, so you're talking about the difference between like fail open and fail close. Yep, you can do either scenario. But yeah, in the end, using these patterns, you can get a much better user experience, right? Because if for example, your default behavior in your web app is I'm going to try to connect to this service, and I'm going to try for whatever the default timeout for a fetch request is, if that's, I don't know, 10 seconds, 15 seconds, 30 seconds, if that's never going to ever return because it's never ever going to be healthy, it's better if you have something that can just return a failure right away, and then like you were saying, if your application can recover from that failure, it's at least going to be faster, right? Because you're not wasting time waiting for something that's not going to respond. And there's this larger ecosystem of chaos engineering. And so Netflix pioneered this with Chaos Monkey, and that eventually evolved into the Simian Army. A lot of this stuff is open source. And so these are things that will do fault injection. So these are things that will intentionally break your services. And the idea here is you should understand what happens in the face of failure. At a big enough scale, it's not a question of if hardware will fail, if different anomalies will be encountered, it's when, right? Eventually you will have failures. And so if you're testing for these failures, then you can have confidence that you can handle them. There was the huge Amazon outage back many years ago where like the entire eastern region was down. Yeah, Netflix didn't even notice, because their fault tolerance, their disaster recovery, their resiliency, all that stuff was already baked in, and it's because they have, the Simian Army going around and intentionally breaking things in random patterns all day, every day in production, so that they see what it's like to respond to those things. And to throw out some phrases that you might hear a lot around DevOps, you've got ephemeral services. And so the idea here is you want everything to be cattle instead of pets, right? The days of having a server that you would care and feed and that you would, name it and love it and nurture it, those are gone. Now you need a new server. If a server starts acting up, if it's the cloud, man, just delete it, rebuild it. I actually did that. The Azure government, the Virginia region had an outage. They tried to do some power testing and something went wrong. They lost power for a while. So if they're trying to test that things can't work without power, they passed that test. But as things came back up, there were just some weird things. And so we noticed some of our services were going really slow. Things that were responding in an order of, like 1 to 2 seconds in the 99th percentile were like 20 seconds at like the 50th percentile. So things were very, very slow. And so what I did, I was like, well, we've got nothing to lose. I'm just going to delete that whole resource group, redeploy it, and all of a sudden, hey, things are working great again. So something happened to the hardware, but we didn't care because we had all that stuff was defined in code. We were able to just redeploy, no problem, easy peasy. And again, idempotency, right? You should be able to, if you deploy the same thing, you should have the same result. It shouldn't have any impact. Okay. New game. Pokemon or technology. Okay? So I'm going to throw up a word, and I want you to say whether you think it's a Pokemon or a technology. Pika. Both! So yeah, there is Pika, of which Pikachu is one, right? There's also Pika, which is this I'm trying to understand exactly what they are. They're kind of like a search for NPM, but specifically for things that will run directly in your browser without having to go through like Webpack or anything like that. So it's kind of a weird thing. So that was your warm up. Next, Spinnaker.
Technology.
Yep. So Spinnaker is a deployment platform. They focus on deployments, right? What about Kaggle?
Technology.
Yeah, so they do a lot of data science stuff. So if you want to try to win some money, they've got some data science challenges that I think the purse for some of them are in the millions of dollars. But Swell it. Pokemon. Okay, some people are diehards here. Molepig.
Technology.
It's both. Yep. So I don't even know what that one is, but I found it today, so it's real. Istio. Technology. So this is, I specifically didn't use their name earlier. This is Google's service mesh that they're making work very well within Kubernetes. And then last one, Zipkin.
Technology.
Yeah, it needs to be a Pokemon. I mean, it sounds like a Pokemon name, right? But yeah, Zipkin is for distributed tracing. And if I didn't explain that before, distributed tracing is where you want to gather information about your service as it goes through all these different hops. So if you've got a microservice where you're going through, let's say 10 different services for a single request, distributed tracing is how you're going to figure out how much time you spent on each one of those. If you've got distributed systems, you need to have distributed tracing. Otherwise, when somebody says something's slow, you're not going to have any idea what that means. Okay, so we talked about a lot of these ephemeral throwaway things, but what about persistence? Right? There are things that we need to have persistence for, right? So databases, some ideas here. NoSQL. NoSQL does not mean not SQL. NoSQL literally was a Twitter hashtag that somebody made to stand for not only SQL. So it is meant to encompass more than just SQL. So there are lots of different database technologies. There are, relational databases like MySQL, MariaDB, Postgres, Oracle, the Azure SQL. There's also graph databases like Gremlin. I'm trying to think of some of the other ones. What's that? etcd. Yeah, a lot of key value stores. DynamoDB. Yeah, Mongo can be, Mongo is kind of more document database, but it's essentially a key value type thing. It's just a very specific type of value of a document. When you're looking at these different things, you need to consider what's called CAP theorem. CAP theorem used to be stated as being a very absolute thing, and it's where if you draw this triangle where you've got consistency, availability, and partition tolerance, as you shift toward any one of those things, you're shifting away from the others. And so if you want a database to be very, very highly, if you need your system to be very highly consistent, then it's not going to be highly available and it's not going to be partition tolerant. Right? If you need it to be very highly available, you're going to give up on consistency some, and you're going to give up on partition tolerance maybe a little bit. Some of the newer systems can actually navigate some of these problems a little better. They kind of merge together a lot of technologies, and so you have things like, in Azure, you've got the awesome DB. What is that thing? Cosmos DB. They changed the name a while back. Originally they called it just Document DB, but it's now Cosmos DB, and it's global scale, and they have, sub-second query times where you can make it as consistent as you want, and it'll still keep that same level of availability, but you just have to pay more because they're doing a lot of fancy stuff behind the scenes. But they have it where you can actually shift that dial from, I don't care about consistency, and so you can have that eventual consistency. That's the easiest way to do these things, right? That's why a lot of these, like Cassandra and Mongo, they came out and it was like, oh yeah, we can do this horizontal scaling, where you can just create another copy, another copy, another copy, another copy, and as long as anytime somebody reads from a database, it's good enough, it's okay if you say, it's going to be a minute or 10 minutes or an hour before this write that happened to node 1 is actually propagated to all the other nodes. If you can tolerate it, it makes things easier. And so you can imagine like your suggested items when you go to Amazon. So if you go to Amazon and you're looking at a product and it says, oh yeah, other people looked at these things. If it's an hour stale, is that really going to make a difference? It's probably not going to be a game changer, right? So that's something where you can tolerate probably an extreme level of staleness there. Whereas if we're talking bank transactions, where I'm withdrawing money at the same time as my wife is withdrawing money, the bank is going to want to make sure that that is absolutely 100% consistent, right? Because otherwise we could be withdrawing from different systems at the same time, and now it's which one's going to win in the war of the rights, right?
Trade transactions.
What's that?
The trade transactions.
Yeah, a lot of transactional type stuff. You use transaction in the name there, right? Anything that's transactional is going to be more likely where you're going to care about consistency. That said, there are ways to enforce transactional consistency through some of these eventually consistent databases. There's an online bank that uses Cassandra as their backend, and I don't know exactly how they do it, but they're able to do it. And it might be that it has to rectify things after the fact. And then the idea of polyglot persistence. That's where, if you think of like Amazon's web front, you go to Amazon, there might be at least a dozen different databases that you're actually interacting with. And that's because at their scale, it's important enough to have the different performance characteristics and behaviors of the different databases that they're willing to have people learn all these different database technologies to use for specific use cases. And this might be something that you find useful. So you might have, it's very easy to find people with expertise in relational databases. That's what a lot of people are very used to. And that might serve you very well for 99% of your stuff. But there might be some stuff where you need a very fast cache. And so you might use something like Redis or some other kind of key value store where you want to very quickly be able to pull stuff out and just have faster response times and stuff like that. So it might be worth adopting some of that polyglot persistence in order to get some benefits in different areas. But the more technologies you have to learn, the more you have to train new people on, the more you have to keep your head around, and the more different systems you need to understand how you're going to tweak them and manage cost and scale and all that. So another way to make polyglot persistence work very well is event-driven architectures. So in an event-driven architecture, it's very common to have message queues. So Kafka is a very popular message queue that was made at LinkedIn, and the reason they made it was for pretty much exactly the example I was talking about. They had things where when you went and updated your profile, they wanted these caches, these read caches, to be updated right away. And they wanted that to be able to respond very quickly to traffic. But they also wanted kind of a more long-term, kind of colder storage for this type of stuff in case a cache needed to be rebuilt. And so they built Kafka so that, for example, if you changed your profile on LinkedIn, it'd put that message into Kafka, and then things would subscribe to messages there, and then they would pick it up, and you'd have independent things working. And that way you don't have to have the thing that's responsible for doing the writes or for doing the update. It doesn't have to be responsible for where those actually get persisted to disk, to database, whatever. And that way you can manage that independently. Makes it easier to adapt new technologies, can make it easier to do a lot of things. But again, you're adding more steps in your process, so it's going to potentially be a little slower. It's also going to potentially be more complex to understand what's going on. Oh yeah, one buzzword that I didn't put up here is CQRS. So CQRS is Command Query Responsibility Segregation. And that's the idea of something that is a command, so that's like an insert, an update, a delete. That is going to be completely separate from a select, where you're going to query for information. And so doing something like having a message queue in between can help you with that. It helps keep those completely separate concerns, so you can even have those be using completely separate technologies. And then the ways that you can use these queues and these event-driven architectures. So you have something, create an event, and it puts it out there for the world to see. You can have things that use event loops, kind of like how Node.js runs. It's just an event loop that keeps going over and over. Or you can have things that are more trigger-based. There's a lot of cool stuff in Azure. I'm going to talk about Azure a lot just because that's what I'm most comfortable with. That's what I use the most. But there's stuff where you write a message to a storage queue. It's going to automatically be able to fire something off. It can create an Azure function that'll just run and then disappear when it's done. Or you can have things where it's based on events in your databases and all sorts of different triggers. Triggers that can be tied to a consumption-based service are going to be a lot of times the biggest bang for your buck. Right? That's where, especially if it's an infrequent event, you're going to be able to save a lot of money because you've got it where you don't have infrastructure when you're not using it, and then it's just going to spin up and it's going to do something when it's needed. Another idea around that is webhooks. And you can tie webhooks together with triggers. But the idea with a webhook is where you're calling back to something when you want it to do something. So for example, Slack, you can create a webhook in Slack, and you can just have a process where it calls out to that URL with a certain payload, and then that's going to cause a message to pop up in somebody's Slack. So now, show me the runny, right? That's what we call running software, right? The runny. I think that's normal, right? Maybe not, maybe not. So continuous delivery. So this is where we take that whole idea of continuous integration and we take it to the next level. And so this is where, when we do a build, we're triggering a deployment. And that deployment does not necessarily equate to a release. So traditionally speaking, a lot of people might mix the terms of deployment and release. I would say that there are differences though. When I release something, I am having that feature be available to the public, right? But I can deploy it without having that feature available. So one of the ideas there is feature toggle. There is a cool company called Launch Darkly, and they have the coolest tagline. They are Booleans as a service. So they do feature toggle for you. So it's essentially, it gives you a hook where you can figure out if you should or shouldn't show a certain feature. So you can have it deployed but not visible. You can have gated deployments. So this is something where, just because you're doing continuous delivery doesn't necessarily mean you don't have verification that, different people have signed off on your code, that security scans have been run, and if there's external penetration testing that you need to have done or something like that. It doesn't mean you aren't having that done. It just means you're probably going to want to have that automated, to communicate back into your system to say, yep, we're good to go. So it's going to be able to proceed to the next thing. In Azure pipelines, that's something that they're expanding out, where you can do more and more there, where it can have, a web API that it can call, and it'll call it at a certain cadence, and when it gets a success, if it gets a 200, then it's going to say, okay, I'm ready to go on. So you can build whatever complex logic you want for what it means to be allowed to deploy. Canary deployments. And I'll kind of mix canary deployments and blue-green deployments. They're very similar. The idea here is, if you can duplicate your infrastructure, what you can do is if you've got, so let's say you've got 5 versions of a service already out there, or 5 instances of your service, and now you've got a new version that you want to deploy. You can deploy one of those, and you can start to load balance some of the traffic so that, let's say, 5% of all traffic goes there, right? And you can start gathering response times. You can start gathering, how many errors you're getting and stuff like that. And you can figure out, does it look like it's actually working the way we said? And you can start feeding more and more traffic over. And now you can deploy another instance and another instance and another instance. So the idea with a canary deployment and a blue-green deployment is you want to be able to deploy the new version and test it with some amount of workload and verify that it's all good without necessarily opening the floodgates and having everybody use that. And that also gives you the ability to self-heal, where you can say, okay, things aren't going so well, I actually want to go back to the previous version, no harm, no foul. And instrumentation is huge here, gathering telemetry. A lot of things you're going to be able to gather telemetry just from whatever service it is you're using. If you're using a VM, there are going to be a lot of things that you can gather from the process monitors inside of your operating system. If you're using like an app service in Azure or something like that, you're going to have telemetry you can tie into there. But there might be some extra stuff that you want to pull. And so if you can instrument it, and so what I mean by that is you might grab a library or something like that. So for Zipkin, for example, you can put libraries into your code that now cause it where every time you're doing an HTTP request, it's going to add extra headers. And those headers can then be passed along to the next thing, which then can look at them and then pass them on to the next thing and the next thing and the next thing. So instrumentation can be very useful for being able to consistently grab telemetry from all these things. And A/B testing is kind of a variation on like blue-green deployment or canary deployment. But in the end, it's basically the same. It's where you have multiple versions of your stuff. But in an A/B testing scenario, a lot of times it's not around necessarily what are the response times, what's the throughput, how many requests per second can it handle. It's more around what are the user behaviors that we're experiencing as a result of our change. So Amazon does these things all day, every day. So, I could look at Amazon and any one of you could look at Amazon and we could have slightly different things going on. It might be slightly different placement of different buttons. They've tried things with different fonts and where to put the text of buy and stuff like that. I know eBay did a lot of stuff where I forget exactly how it went, but there's a lot of stuff you can read about how they chose whether or not to put the buy now text directly on the button for buying now or to put it below it and what size and what color and all those things. There's also a lot of bad stuff you can do there, and you don't want to do that. So if you want to learn what you should not do, there's this whole idea of dark UX, and there's a lot of stuff going on out there that is not ethical in my opinion. So be aware of it. Definitely don't go to those things as a tutorial of what you want to try to do to drive traffic to your site, but see those things as maybe some unconscious things you might be doing and try to avoid those patterns. Okay, and so last slide, because we've gone a while. Special bonus words. I'm just going to throw these out there. IoT, intelligent edge, blockchain, big data. So IoT is Internet of Things. I'm sure we've heard of these things like smart thermostats. That's a form of IoT. Smart toasters, smart microwaves. Yeah, smart toothbrushes. There's self-lacing shoes. The MBA is using these like $500 Bluetooth-enabled smart shoes that can change how tight the laces are based on the pressure that they're giving as they're jumping. I'm waiting for somebody to figure out how to hack those, and all of a sudden in the middle of a game, somebody's foot starts like going blue or something. It's gonna happen. So that's IoT. Where you see a lot of it though is in factories, and machinery. So these are things where they're gathering telemetry about hardware, such as temperature. And so they're able to do things like have IoT tied into these heavy farm equipment where they've been able to show that, when the average temperature of the engine goes up, this many degrees, there is a statistically significant chance that it is going to break down within the next week. So pull that thing, let's do some maintenance, preemptively. And so you can imagine all these sensors doing all these things. That's a lot of data. Yeah.
Saw a presentation from Stryker out of Kalamazoo.
Okay, yeah.
They do medical equipment. They do like the robots that will do the surgery.
Okay.
They were saying that one of their machines, or one robot for one 8-hour surgery will generate 1 terabyte of text data.
Yeah, so a lot of data, right?
So their equipment's all over the country, so they're dumping it up to Azure to collect it, essentially.
Yeah, and so they might do some stuff that you consider the intelligent edge. So the intelligent edge is where there's so much data that network bandwidth is a bottleneck, right? So you can't send just all the raw data. So there might be some machine learning going on the device, or there might be some compaction going on the device. And so some of these temperature sensing devices, you can imagine a very common thing might be, only point out, maybe the maximum temperature, minimum temperature, and average temperature every 5 minutes, or whatever it is you need. That could be one way to be able to take huge amounts of data and compress it down so that you're able to much more efficiently send it out. Or there are actually hybrid models of that where you might have, like on oil rigs that are out in the ocean, they might have sensors that are gathering some data, and they might do some data compression and then feed it into a server that is on this rig that is going to do some machine learning and analysis of that data. And then some of them will actually then take a suitcase of data back to shore, or they bulk upload it via satellite at a certain time of day or something like that. I've heard a couple strategies, but Software Engineering Daily, if you want a good podcast with lots of variety of stuff, he does have an obsession with both ad fraud and oil rigs, so lots of stuff around those things. And then blockchain, if you're not familiar with blockchain, it's the idea of a distributed ledger. So blockchain is a really slow, inefficient database, but is really useful if you can't trust anybody else, right? So if you don't have trust, blockchain can be a great thing because it's using consensus to validate all the transactions that have happened. So with the blockchain, as you put something onto it, you're going to have everybody has these different copies of it, and there has to be consensus of, yes, we agree that this event happened, we're going to add this to the chain, this is now part of the history, and therefore that history cannot change, theoretically. There are caveats of like 51% attacks. That's where over half of the network is coordinating a deceit.
Alteration.
Yeah, so they're coordinating that, yeah, we're going to agree to change history. But yeah, so blockchain, it's a thing. You might care. I don't know. I don't have any use case for it myself. I find Bitcoin interesting, but that is just one of many ways of doing blockchain, though. And then the last one, big data. It's just a lot of data, right? I mean, you can have lots of data and still not have it be useful, right? So you need to have good ways of analyzing your data. Because if you're just storing data with the hope that it might be useful, it might eventually be, but in a lot of situations, there's actually the case where you gather so much data that you start to get false indicators in your data, where a really good example was it was a study on diabetes treatment, and they were looking at diabetics where there was a certain behavior where if people came in with certain symptoms, there was a certain treatment that they would try to give them, but only if they were at a specific hospital. And that was what the machine learning was trying to say, is that, oh yeah, the geography dictates what the treatment should be. And nobody could figure it out until they finally realized that, oh yeah, people were given these anonymous IDs, but within these IDs, these randomly generated IDs, the hospital location was in that ID. And it just so happened that that one specific hospital was like, an ICU type, bring people as they're almost ready to die type place. And so the treatment was actually contraindicated because it would kill you if you weren't like already on death's door. So
That's evil AI.
Yeah. Yes, evil AI. Well, AI can only be as evil as we allow it to be.
Yeah.
So
That's true.
that's another topic that I've talked about in the past is ethical computing. So there's a lot. I have a lot of opinions there. And as promised, I do have a couple links here. A really good example of a lot of the DevOps practices in one big bundle is 12factor.net. And that's actually what a lot of Heroku's stuff was based on. They implemented essentially what the 12-factor app pattern is. So if you go to 12factor.net, it just has several principles that you can follow. And then I also have the URL of Martin Fowler's blog where he talks about microservices. And then the last one is an expansion on the image that I had where I was showing the different things that you need to be responsible for if it's on-prem versus in the cloud, software as a service, platform as a service, etc. So I have gone through a lot of terms. Yes.
You were talking about more stateless, to have a stateless applications, right? But Source Vector app, .NET, they keep the app as stateful. Do you know why stateful is? Because they say better to keep it on the database than you keep it on the memory, and so that you always.
Okay, so I think what you're saying is that's actually how you could make your app stateless.
Okay.
So what you're describing is stateless. So in a stateless application, the persistent things about you would be in a data store somewhere, in a database, not in the memories. And so the example, so like where I said if your login, if your session ID is stored in memory on a VM, then you can only be authenticated to that VM. If instead you take your session token and all that and put it in somewhere else, a Redis cache or in a database of some sort, then you no longer are tied to that VM. So your connection to that VM from that perspective is now stateless. So the idea is if you go to an API, right? That API should not need to know what your prior request was to be able to answer the current request. If to be able to respond to the current request, it needs to know context about your prior request, there's a good chance that that's not a stateless application, right? Does that clear that up?
And also they talked about not to have sticky sessions.
Yep. Yeah, sticky sessions, it slows it down. It's easy enough to implement, but again, if you're relying on being tied to a specific VM, what happens when that VM goes down? What happens when you take it down because you want to do maintenance and stuff like that? So if it's stateful, you're going to have to go to that. You have to go to where the state is. But if you store the state, if you take that and store it somewhere else, like a database, you can consider that to be stateless.
Okay, thank you.
Other questions?
Sorry, I'm a little behind. I don't know what Redis. What is
Redis. Okay, yeah, I've said Redis several times. So
Yeah.
Redis is an in-memory database, and so it's meant to be very fast.
Oh.
So you'd use it for caching. It's not.
So it sounds like a service.
Yeah. A lot of times you can use it as a service. You can run it yourself, but like in Azure, there's a version of it. There's similar technologies other
So
places
open
as
source
well.
thing or open source?
Yeah, Redis is open source, but they were one of the people that changed their license lately, along with Mongo and some others. So I don't actually use Redis at all. We use Cosmos DB some, and Cosmos DB has been improved so many times over that it is now fast enough to treat it.
That is an Azure thing.
Yeah, that is an Azure thing. Yeah. Yeah, I don't even think you can run it on your own server. There's an emulator for it, but the actual Cosmos DB, I'm pretty sure that you can only do that in their cloud.
Microsoft.
Yeah, but yeah, I'd say Redis is something that you'd use if you wanted a caching, like a distributed cache.
Sounds
But
interesting.
you can save.
What's that?
But you can save.
Yes, you can persist it.
You can persistence disk. Memcache you can. If
Yeah.
you were to use Memcache.
Right, yeah, Memcache is another
Oh, I've heard of
option.
Memcache.
Yeah.
Okay.
Other questions? Yes.
When you were talking about configuration management and source control,
Mm-hmm.
you talked about Node, and it seemed like you were saying that having each developer run Node or npm install on their local machine can cause conflicts. So what would be the alternative to
Okay,
that?
so you've got a couple options. Particularly with npm, right? You've got the option of you can do npm install locally, and npm as of the latest versions, as well as Yarn, since the beginning of Yarn, they have lock files. If you commit that lock file to source control, then you can have your build server, instead of doing npm install, it can do npm CI, and that will only take exactly the versions of everything that's in the lock file.
So when you say build server, I guess I think of it in terms of I've got my local site, like a staging site and a production site.
Right. So depending on your workflow, it would, and so this is where if you've got multiple people developing, it's good to have a single thing that is responsible for building and deploying to your staging site. And that could be any number of things, right? You could use something like Circle CI. There are lots of ways. There are people who do it through Git deploy, right? So Heroku's an example of that, right? So with Heroku, you set Heroku as a remote for Git, and you say Git push Heroku master, and it's going to push your code to Heroku, and Heroku's going to build it at that point in time. Then if you have a different Heroku destination for it, if you've got multiple branches that represent different environments, I'm assuming it's going to do some rebuilding there. And so that it brings in at least a slight chance that things are going to be different. People, NPM relies a lot on people's GitHub repos. They can technically make changes, People can drop repos, such as the whole pad left fiasco that happened years ago. In case people aren't familiar, I'm throwing out other things that are kind of, insider knowledge type things, I guess, if you didn't know what it was. But pad left was an NPM module that this guy had maintained, and it literally padded the left side of text. So you could have it, if you had a monospace font, it would make things line up nice and pretty if you had certain layouts. And you can imagine, I'm sure you can picture in your head right now what the source code would be to create a stupid little loop that says, okay, how many times do I need to pad some space in front of this thing? But rather than people writing that code themselves, they just said, oh, there's this node module for it. I'm going to use pad left. Well, the guy decided to delete his repo because he was having an argument over the name of a different package that he was using, or that he had created. And so he deleted it, and it broke a lot of the internet for a major portion of a day, because there were dependencies of dependencies of dependencies that pretty much everybody was using. And so that's a situation where you could have pushed it to staging in the morning, and it built fine, and it deployed. And then in the afternoon, you push that same code to prod, and it tries to build, but it can't get the package that it needs to install, and so it doesn't work. So that's where you can have more consistency if you have a single thing that builds it once, and then you push it everywhere from there.
Okay. How do you build once and also develop on multiple local machines?
So as far as a continuous integration workflow, so you're developing on multiple machines, and you're going to build for yourselves on your
so you'll
individual
build
machines.
locally, but then
Right?
there's a
Yeah.
single source of
Yeah,
truth
but kind of the real build.
Okay.
The build that's going to be deployed. And I would even say, I'm gonna kind of soften the blow a little bit. If you have, for example, if you have something like Artifactory or something like that, or some sort of an artifact repository, I would say it's okay for you to build it on your machine, and you push it to that repository, and in that scenario you were the build server, and then what's deployed is always going to take that copy that you pushed, right?
Okay.
What I don't like, and this is built right into Angular. If you create an Angular app from their Angular CLI, it will automatically have different build targets for like dev and prod. And it does tree shaking, which is where it looks for code that is not hit when you're in prod mode versus dev mode, and it removes that source code to try to make your bundles smaller. Okay, that is by definition a completely different set of executables, right? The code is different for prod than dev. So I don't advocate for that at all. The way we do it at Spring Court for an Angular app is we, locally you do npm install. It creates that lock file that has all the specific versions of every single library and every single dependency, right? You push that to our repo. So we use Azure repos. And then what happens is our Azure pipeline picks up that there was a change, and it's going to do npm CI, where it's going to package up the artifact. And then those few things that need to be different, because, you taking off? All right, see it. I said for your application, you should have your configuration in the environment, right? So you should have your environment variables on a server. Right? Well, that doesn't work for a UI or for a client web app. Right? So if you've got an Angular app that's running in somebody's browser, you can't set environment variables. Right? So you typically have to have some sort of a config file. So the way we do it is we take all that environment specific config and we pull it out into separate files for dev.config.js and staging.config.js and prod. And then what we do is at release time, we pick the one that we need for that environment and we change the name so that now the application uses that. That's the way that we do it. I mean, another option you could do that I don't like quite as much is you could have logic in your app that says, what's the domain name? If the domain name says dev in it, do the dev things. If it says staging, do the staging things. So.
Where do you keep the repo? Where does it reside?
So for Azure, the kind of source of truth repo is Azure has it. So it's in their cloud offering. So similar to GitHub, right? So which they now own, of course. Yeah, Microsoft bought GitHub a while back. And they're actually talking about GitHub is going to be their enterprise deluxe experience for Git. But you can use the Azure repos and they're free. So
That's not the portal, the Azure DevOps.
Right, yeah. So that's part of Azure DevOps.
Right.
Azure DevOps is Azure repos, Azure pipelines, Azure teams, Azure Azure test, and then Azure package,
Right.
I think it's called.
Azure board.
I said Azure Teams, but yeah, it was Azure Boards is what they call it, yeah. But if you think about it, Git is distributed version control, so there's no actual, centralized thing, but we treat it that way, right?
Yeah.
That's what GitHub.
Yeah, it's an abstraction.
Yeah, GitHub's all about that. Azure pipelines. Most all the services work where there's a thing that's centralized that you treat as kind of the real thing.
Yeah, it's fault
When
tolerant.
you said build once, but does that mean like if I have different branches, so build per branch once?
Okay, you stepped right into this one. So I am not a big fan of branches.
Okay, so
and actually, in the Accelerate book, they talk about the research that they did for high-performing teams. They would say the highest performers do trunk-based development. So that means they're always in master.
Okay.
They are never working off of branches. But then they expanded their research and said, okay, we know a lot of people like branches, so they can't be all evil, can they? And they limited it to basically, if you were a high performer and you had branches, guaranteed it was no more than 3 branches, and they lived no longer than 1 day. So that is my comment there. And yeah, this is actually something where so when I was at Vertafore and we were switching from Subversion to Git, we were like, oh yeah, there's this whole GitHub flow and all this stuff. Oh yeah, we should create like a development branch, and then that'll merge up into this, test branch, and then that can merge up into a UAT branch, and then eventually it goes to master, and that's what's in production. And my boss at the time was like, no, that's stupid. You don't want to do it that way. I was like, yeah, whatever, you don't know. And now I'm like, he was right. He was very, very right. So that was Ernest, in case you were wondering.
I figured.
Yeah, so now I'm totally, like, I always work in master. I try to, push my stuff in every single day, and only the builds on master matter. And so I'm going to guess that I wasn't as clear as I wanted to be. When I say build once, what I mean is in the context of your deployment. So when you're ready to deploy, wherever it's going to deploy to, right? Because you should have a sequence of it deploys to whatever your flow is. If it goes to dev, then it goes to test, then it goes to a demo environment, then a UAT, then a staging, then a production. Whatever your flow is, when it first starts that journey, build it once.
Yeah.
Do not rebuild it for each of those different environments. When I was at Vertafore, when I first started, we would build for the environment because that was just the way that we built everything, it was easier to get the environment-specific configuration in there by rebuilding. But that there were so many times where you'd end up screwing things up, hopefully not screwing it up to the point where it was deployed to the end users, but you'd screw things up where you grabbed the wrong version of a branch, you grabbed the wrong branch, or somebody made a change after you'd made one of the builds, and you'd end up missing stuff that you really needed there. So build once.
Not to mention, if someone actually finds a problem in one of the 4 environments in, then you have to repeat that entire process of build, deploy, build, deploy.
Yeah. That's another thing to consider is even just the time that it took to build. Some of those apps were 30 minutes.
But some developers' argument was if we build it per environment, let's say tomorrow somebody asks, hey, give me the package, I want to deploy into production. They say, okay, take this bundle, it's already built and it's for production, take it and install. You do not have to go through a pipeline. If you have a pipeline, then it makes sense.
You can still do it. You can still do it. I'll actually, this might be a little awkward, but we'll see what I can show. Man, the glare is not the best. I don't want this guy, but trying to think of, here's a good one. So if I look at this pipeline, I know that I built it once.
Yeah.
This is the version that was built. And so I can click here, I can find the exact artifact that was built. And then I see that deployed through to dev and to demo. And then here I can just say, yeah, I want to deploy it to prod. Right? And if I want to see what was previously deployed to prod, I can see that as well. I'm trying to think of how, I know there are different ways of doing it. I've actually built some of my own tools to do some of this stuff because it is a little clunky. The release portion of Azure Pipelines was something that Microsoft acquired, and it is a little obvious at times because it feels a little clunky compared to some of their other stuff. But I should be able to, oh yeah, so right here I can see this is what was previously deployed to prod. And so if I knew that I wanted this artifact to be deployed to prod, but I wasn't ready for this one up here, what I could do is I could come here and say, oh yeah, I want to go into this pipeline with that artifact, and then here I'd just say deploy. Okay, so what you're saying is, what if there was an artifact that was specifically for prod? What I'm saying is any artifact can go to prod.
But when you do to prod, then only the prod specific variables gets injected to your package. Right?
Yep.
Because your package still will have some dollar variables because you might have kept it in order to get injected when you are deploying base specific environment.
Right. And so this one in particular, we were talking about reverse proxies. That's exactly what this does. And so what it's going to do is here, this is where it's going to deploy its ARM template. So this is the actual infrastructure definition. Then it's going to come here, and this is where it gets that specific thing. So it says copy environment specific files. And so this, just like the Angular example I was saying, I have specific files. These are web config files for IIS. There's one that's dev, one that's demo, one that's staging, and one that's prod. And so the only piece that's changing is that config file per environment. And so right here I'm just saying, yeah, go ahead and swap out for the one for this environment. So here it's just saying, what is my environment? And so it's figuring out that, oh yeah, this one is prod, so I need to grab the prod configuration file. So I'm going to swap that out, and then it's going to actually, so it's grabbing the credentials for how it's going to FTP these files, and then it's going to just FTP them out.
So if you have, let's say, 5 people working on the same project, do they each work in master, or do they have to make a branch then push it into master?
So some of the teams have chosen to work in feature branches and force a pull request to be able to merge in to master, but they're still all working in a single branch. If it's 5 people, 10 people, whatever. I would argue that it doesn't matter how many people you've got working in a branch, as long as you're not working in the same file. Git is going to be able to do a very good job of merging and be able to resolve conflicts. And even if you are working in the same file, as long as you're committing frequently, pushing frequently, it should be able to resolve most issues. I don't know, did that answer your question?
Yeah.
Okay. Yeah, I mean, I'd say have as many people as you want working in master.
I think the problem I might run into is not being able to do it frequently. Because some people are going to be having, for the project I'm particularly thinking of, there's some people are going to have a longer development cycle than like this change over here. I might be, one person might get through like 5 changes.
Right,
While
right.
this one person is maybe dealing with one change at that same time period.
Yeah, so what you're talking about is you've got concurrent feature development in the same code base, right? And so that's where you can make choices, right? So one choice would be split them out into their own services, right?
Can't do that.
Okay, if you can't do that, then another thing you can consider is feature toggle. If you can toggle things off,
Can't do that.
I'm not going to say it's easy.
No, I can't. I'm making config files for a product we bought,
Okay,
so I can't. There's not a.
I see what you're saying.
I don't have. There's not a feature toggle in
Therefore,
my
Okay,
config file.
okay. So actually, yeah, so I had a similar situation. When I was at Jackson National, there was one of my employees, she had these XML files that she had to manage that kind of were config type files, and they were based on these external XML definitions for different forms development and stuff. And so she would get things that would come in, and she'd be working on them and have to have them ready to go, but then maybe a downstream system wouldn't be ready, so she'd have to back out some of the changes but not all of the changes. And so for her, I actually did advocate for keep it in separate branches, and when you know it's ready to go, merge it in. And so that might, it depends on the context for you, that might make sense for a config file if you have kind of, here's my list of branches, and when I know they're ready, merge it in, merge it in, merge it in.
Well, I'm talking configs. I'm talking like these are hundreds of config files. All
Yeah.
In various folder structures. So.
Okay. Yeah. Yeah, so you might need some sort of a flow to be able to ease them in, kind of a feature toggle of sorts, but more at the build level versus the deployment level. Are there any other questions? I know we've kind of gone over time a little bit. All right. Well, thank you everybody for coming. I hope you learned some things and enjoyed it.